So till now we have seen how is the electronic configuration of elements changing in a periodic table, that is in which period which are the orbitals that are being filled up. We have discussed on the basis of this particular table. We should recall it. In first period only 1s orbital is filled, and in 1s maximum 2 electrons can be placed. So how many elements will it have? 2 elements will be present. In second period the orbital that are being filled is 2s 2p, same as with third 3s 3p. So here both will have 8 electron each and 8 elements. 4s2 3d and 4p are the orbital that are being filled in fourth, so the number of electrons that are being filled is 18, same as with fifth period. In sixth the orbital that are being filled is s with a maximum of 2 electron, f with 14, d with 10 and p with 6. So maximum 32 elements are placed in 6th and 7th period. So far we have discussed about the arrangement of electrons on the basis of electronic configuration. In the modern periodic table, the base is atomic number, and if you know the orbital that are being filled in which period, we can tell in which period how many elements are present and why the two rows are placed down, and these are not 8th and 9th row, but in fact they are the part of 6th and 7th period, and these are called lanthanoid and actinoid as they have different arrangements. So we shall see now the electronic configuration in a particular group. In a group in vertical column, they have similar outer electron configuration, same number of valence electron, and hence they share similar properties. That is, now when they have same outer electronic configuration valence electron, they will have similar properties. For example, if you talk for group 1, the members are lithium, sodium, potassium, rubidium. Now these all share same configuration in the sense that lithium has configuration 2s1, sodium 3s1, potassium 4s1, rubidium 5s1. So in the s subshell, how many electrons are there? 1. So the valence electron is 1, and they will have 1 electron in the outermost shell, and the reactivity will have all these elements will have similar kind of reactivity. That is why we tell the electronic configuration plays a very important role in telling us about the periodicity. If the elements that are placed in the same group have same kind of valence electron, the chemical reactivity will nearly be same, that is they will have similar properties and outer shell electronic configuration. Now we shall see the different group in modern periodic table, or different columns in modern periodic table. Now there are 18 columns in modern periodic table. Let's discuss, for example, the first group called as alkali metals. Now in this you have lithium, sodium, potassium, rubidium, cesium and francium, and in this francium is the more. Now here you can see an element called as francium. This is a radioactive element. So we don't know much about the properties because radioactive are highly reactive and they are spontaneously emitting radiations which are harmful. So majority of the properties of francium is not known to us, but still maximum properties we are aware is for the rest of the elements, and we'll talk with reference to these elements. Now if you see the outer valence shell, the orbitals that are being filled is s orbitals, and they contain 1. Only the principal quantum number is changed, and the principal quantum number is equal to the number of period in which they are being placed. For example, lithium is in second period, so it's 2s1, the outer shell. Sodium is in third period, so it's 3s1. Potassium is in fourth period, so the last electron is in 4s1. So this is the similarity that you find when you talk about the electronic configuration. Now so far we have discussed for group 1. Now the elements, how are they arranged in the modern periodic table? We came to know that on the basis of the electronic configurations, the elements are placed in vertical column called groups having similar electronic configuration. That is, the electron, the valence electron enters into which subshell, the group are being allocated for them. Now for alkali metals, we have seen group 1, the last electron or the valence electron enters into ns orbital with 1 electron in its outermost shell. Now the elements which are placed in the group have similar properties, and in order to avoid such confusion about the properties, group 3, the elements we can see that are scandium, yttrium, lanthanum, actinium, and the rest elements are at the bottom because these elements are a part of group 3. And to avoid any discrepancy, that is to have any anomalous behavior, these elements have different properties as compared to rest of the third group member, so they are placed at the bottom of the periodic table. Rest all the groups have elements having similar physical and chemical properties. Now, periodic table is also classified into S, P, D, F, that is on the basis of which the electron enters into which orbital, which it's S block, P block, D block and F block. If the last electron enters into S orbital or S subshell, it's S block, then P block, D and F. So in which orbital or in which subshell electron enters, the valence electron enters, it's being classified into 4 different blocks. S is on the extreme left, P on the right, and helium, you can see it is an exceptional, it should be placed in S block, but the properties of helium are more similar to that of the next noble gases which are being present, neon, argon, krypton, xenon. So it's placed in group 18, and these are called as noble gases as they have stable electronic configuration. Now what happens over here is, you can see that in helium it has only one orbital, so maximum of 2 electron, so it has fully filled electronic configuration. Similarly, the other noble gases have 8 electrons, and this also has 8 electron fully filled stable electronic configuration, due to which these and helium have similar physical and chemical properties. So they are stable, I can tell it is extra stable due to fully filled outermost shell electronic configuration. Hence, group 18 has helium even though it does not have any electron in p subshell. As helium does not contain any p subshell, even then it is placed in group 18 because of its similarity in properties with next or with the remaining noble gas elements.